Hello. So I want you to take a moment and pause the video right here, reading all of this. All right, great. So did you notice that he gave us a handy dandy little device to decide whether or not something is concave up or concave down? I wanted to sort of add on to that you don't have to have the whole cup to call it concave up. Just this piece right here can be called concave up, even though it's half of the cup. This here isn't the whole down facing cup, which I like to call a hill. But this piece right here is still considered concave down. So, when you're looking at the piece, the part that matters is it arching up? If it is, then it's considered concave down. Is it arching down? Then I would call it concave up. All right, so here we are looking at looking at our graph, and I was looking at it. I want you to know this piece right here is considered to be straight. I couldn't tell right away when I was looking at it, but he definitely intended for it to be straight. And then also, I didn't notice that right away, but this little piece as well is supposed to be straight. So if you wanted to know, let's go ahead and attack number 3. On which intervals does the graph have no concavity? It's where it's straight. So I'm saying from 3 to 4 and from 6 to 7. That was his intention, is for you to be able to see on that graph that it's straight. All right. So being very careful with the rest of the graph, I'm going to say that this is half of a cup. Okay, it's a long, narrow cup that would look like this if I had both sides. I don't have both sides, but I do have concave upness right there. So I'm going to say this is -2 to -1 is where I have concave upness. And then I'm looking again at this piece, and that's the whole cup, so that's really easy to identify. It's going to be from 1 to 3. And I'm looking again at this little piece, and it's just half of the cup, but it is still concave up in that little spot from 4 to 5, because right there is 5. All right, well, that means, I hope that it's obvious, that these guys from here to here, which is from -1 to 1, and from here to here, which is 5 to 6, are going to be concave down. As far as points of inflection goes, break out a highlighter, pause the video, boom. The graph has a tangent line at that point, and the graph changes concavity at that point is the requirement to call it a point of inflection. So I'm erasing all my marks just so you can see very clearly. I want it to be obvious that right here is where it changes from concave down to concave up. And right there is where it changes from concave down to concave up to concave down. Now, I know that you like the marks and the colors. So what if I put them all back? Does that actually help? You see how we're changing over from concave down to concave up, and why I'm calling that a concavity? The graph does have a line that I can call a tangent there. This over here, I'm going to highlight it in, like, I don't know, what's this, orange? That's a cusp, so there's definitely no derivative there. And this is also a cusp, so there's no derivative there. So if I can't find a tangent because there's no derivative there, then I can't call it a point of inflection. So point of inflection is going to be in these greens. It's where it changes from up to down or down to up, and you can draw a tangent there. Okay, and my tangent, by the way, let's do this in like this green, would be like that and like that. Okay, so then that means that my points of inflection are from -1, 1. Yeah, that's an actual point. That's an actual point. So there's an x value and a y value here. And then this over here is going to be 5, 1. And again, this is an x and this is a y. And it's not an interval on the x-axis. All right, so analytically, we will find concavity intervals and points of inflection by using a second derivative number line. And it's the same process as what we did before. So flippy, flippy, Pause the video, practice taking the derivative, and see if you can't set it equal to 0. All right, so I'm taking the derivative here, and I'm going to say f prime of x equals 4x cubed plus 3x squared minus 6x, and that is my derivative because the derivative of 1 is 0. It looks to me like I could